Okay, hey everybody, thanks for coming. The pizza's a little bit delayed, so we maybe take a quick break when it gets here, or just as it comes, get a couple minutes, go grab a slice and sit back down. Big thanks to HCA for sponsoring the food and drink tonight. Everybody give them another round of applause. Special thanks to Rodney Norris. He helped facilitate the speaker tonight. And also thanks to Emma, as always, for hosting us here. They were always very, very, very gracious. If you don't know, NashJS meets every second Wednesday of the month. Every month. We're always looking for new speakers, looking for sponsors. So if you're either one of those, contact me. Hit up on Twitter. I'm the word knowledge spelled backwards. It's really nerdy. I'm sorry. And I think that's it. We've got some announcements coming up in the community soon about November. I don't have anything just yet, but hopefully soon. Anyways, without further ado, we've got Elijah Manor. Everybody give him a huge round of applause. It's going to be great.
Thank you. Yeah, so I'm Elijah Manor. This talk, I had some older talks that I used to give about just basically like, here's some JavaScript code, it doesn't work, can you spot the bug, and basically we talked about how to fix it. This talk came about because oftentimes our code works, but there's something about it that we just don't, it just smells yucky. We know that it can be done better, or sometimes we don't even know how to fix it, but we know it's not quite right. So this particular talk, we're going to address several things that are smelly code. We'll talk about why it smells. We'll talk about different ways to fix it. Again, I'm Elijah Manor. Just quick about me, I'm a Christian. I have a family, 1 wife, 3 children. I work at Dave Ramsey. Yeah, only one. Yeah, I'm glad you caught that. Most people don't catch it. I have a very strange sense of humor, so be prepared for that. I work at Dave Ramsey. We just launched a new product called Every Dollar. It's a budgeting tool, and that's what I've been working on. I've done some Pluralsight courses, so if you're interested in that, contact me. I can give you a free month trial where you don't have to pay for it. And basically, I'm a front-end developer. That's me. So the first thing we're going to talk about is crazy complex code. There's some pigs back there. Several years ago, when I was trying to get into blogging, I thought it was kind of fun to. Has anyone heard of Pig Latin before? Yeah, so it's a fake language that's really weird, but when you're small, it's really cool because you can learn another language. Anyway, so I thought it'd be cool to write just a little JavaScript function that converts English to Pig Latin. Obviously, that's very trivial and trite, but it was a good blog post. As I was writing it, I knew it was awful, and I kind of said, well, I'll refactor it as this blog post progresses, so it's going to look awful. But before we talk about the code, Pig Latin basically, it starts with a consonant. You move the first consonant to the end and add a y. So like pig would be a pay, things like that. If it starts with a vowel or a silent letter, you just add the way at the end. So egg would be eggway, which is kind of cool. Things like that. So here's the really awful code that I actually snagged from a blog post I wrote years ago. It's just a big mess, and it just keeps going. So pretty complicated. Obviously, hopefully we don't write that code. It smells. It smells bad. It mostly smells bad because it's so complex. There's a lot of things going on, and if the future me, which is me right now, were to look at it, it would take me a while to grok, to figure out what it's really doing, and why did I have this if statement, why is there this magic number, things like that. So there's this concept in software called the cyclomatic complexity. Some really smart guy in 1976, Thomas McCabe, came up with an algorithm to assess how complex functions are, and he called it the cyclomatic complexity. So what you can do is you can actually run this algorithm against your code, and it will come up with a score, like a number, to tell you how complex your function is. So I ran it against the original version of the Pig Latin code, and it was a score of 7, which might seem a little arbitrary because what's the scale? Lower numbers are better, and really high numbers are awful. There's a website called jscomplexity.org, which kind of you can throw your code in there and kind of see what's going on. but you don't want to copy and paste your code into a website just to figure out what's going on. So there's a bunch of nice tooling to help you figure out, as you're developing your code, how complex is it. Who here has heard of JSLint? Okay. How many have heard of JSHint? How about ESLint? A lot less, but some. So two newer tools than JSLint. So Douglas Crockford made JSLint. It's been around for quite a while to give you static analysis of your JavaScript code, telling you, you should do this, you shouldn't do that. Well, some people in the community really wanted to add things, or maybe take away some options, or maybe make it less strict. But Douglas Crockford, who created it, didn't really want to do that, and it's fine because he created it. So a group of people from the community forked it and made JSHint. It essentially has all the same rules that Douglas has, but even more. And then recently there's ESLint, which Nicholas Dacus created. He used to work for Yahoo. And the cool thing about it is it supports all the rules of all the others, but it's also pluggable. So you can make your own rules. Like if your company, if you want to enforce certain rules in people's JavaScript, you can write it, which is really quite cool. So both JSHint and ESLint actually support the max complexity option. A lot of people don't even realize it's there, but it is. So that's really cool. So we could add that to our linter, either in a JSHint RC, or we could have a comment on the top. And we could tell it the max threshold of complexity that we want for our function. So I'm just going to arbitrarily say 5. And here's a really awful screenshot that you can't see, but it's the JSHint website. You could paste in your code, and it will actually give you a warning that, hey, your code, there's a warning because it's too complex for the standard that you set. So now what do we do? So really, you'd probably put this in your Gulp workflow or Grunt or whatever you use to build your JavaScript to automate this. But once you have pinpointed a piece of code that's too complex, what do? Well, you should refactor it. But before we refactor our code, you should really have unit test coverage, because if you change something, you could break tons of other things. So you want to make sure you have some unit tests first. So I went ahead and wrote some unit tests for Pig Latin, which is really kind of silly, but it's a smart thing to do. So then we are good to refactor. So I made a couple of helper functions to test if things are vowels or consonants. It reduced the scope quite a bit. There's a for loop, nested if statements. It's still not as good as it could be, but our score is not a 4, so it passes our a 5 level across our application. Now, having a nice build tool is not the greatest, coolest thing, and it doesn't show you a snapshot over time of how your project's doing. So there's a tool called Plato. Has anyone heard of Plato? A little more people. And you could actually run this against your code base, and it keeps a snapshot over time of how your project is progressing in complexity and maintainability. So for example, we're going to open this up. So I ran Plato, the tool, and it's also visual, so your manager might like it and think that you're doing cool stuff. So I took a snapshot before I refactored the Pig Latin and after I refactored the Pig Latin. So here's the before snapshot. Now my number of lines actually went up, because usually when you refactor, you're adding extra functions, and it adds a little bit of cruft. But my maintainability score went higher, and that's a good thing. My code is more maintainable because I've actually refactored in smaller pieces. If your application has many different files, which most apps do, then there'll be a bar chart showing each file and how maintainable each file is. So you can actually drill in. I only have one file, but if I drilled into this is the maintainability just for the Pig Latin, and you have all these nice little pie charts. The is consonant function has a score of 2 for complexity. You can kind of pinpoint in your app where the trouble parts are, which is really kind of cool. And I also look at lines of code. And if you scroll down, it'll give you a lot more information about what's wrong and what you should change. So it's a much more visual way to represent what JSHint and JSLint and all those tools give you in the command line. So I would recommend maybe looking at that. And so here's some resources. The slides are at the end. And for each point, I try to have all the resources that I've talked about. So the next one is massive functions. This is actually the output of the previous point, which was better than the original one, but there's still a problem. If you look down here, this function's really, it's not too long, but it can get out of hand. It smells because it's getting large too quickly. It has too many statements. Some of your functions could have too many parameters. Like if you're passing 5 parameters, well, it's getting a little out of hand, and it might be hard to figure out what you need to pass into it or not. And what's really awful with a function if it gets too deep, like there's a for and an if and a switch and an if, that just gets really hard to maintain. So again, JSHint and ESLint provide additional parameters like max parameters, max depth, max statements, and max length. And again, though JSLint doesn't have any of those, so these you might not know these. But these are good to add into your system if you already use these tools. And again, you could add a comment on the top of your file, which is not the best way to go. It's better to provide it in like a common options file. Again, you just decorate your file, and it will give you all the stats. So our particular stats is our pig Latin has 2 parameters, which is not too bad. It has a depth of 3, which that's getting on the edge of acceptable. If it's 4, I'd probably say that's probably not very good. We have 10 statements, which is not too bad for a function. Complexity of 4, again, not too bad. And the max length is 65. Now again, this pig Latin sample, again, is trivial. Try it. You won't use it in production, probably. But what you need to do for your team is come up with numbers that make sense for your project. And obviously, they'll be probably a lot larger than these. So if you start getting warnings for these errors, and again, usually the answer is to refactor. And in this case, I decided to use ES6. Has anyone used the new version of JavaScript in their code? We use Babel.js, which allows us to cross-compile JavaScript or ES6 into ES5. So we can use all the cool latest techniques in the new version of JavaScript. And I'm not really going to get into that, but I also changed the algorithm for this particular thing, but the code actually is a little bit more maintainable. Obviously, it might look like Greek to you if you've never written ES6. But after my refactor, my numbers are mostly better. And my max length got a little gnarly because I was trying to fit things up online. So, but again, the point is not how I refactored things or the tooling I use, but the fact is you need to put these things in place to help guide yourself to figure out where the problems are in your code base. And again, look at JSHint and ESLint. All right, so those are the only options that currently exist in those tools that you might not have known. All the rest of the points, there are not tools in JSHint or ESLint or JSLint, but there are some other tools that you might not know about because they're kind of new to help you figure out problems in your code. This one, copy paste code smell. It's a little obvious on probably what it is. But let's say your boss comes to you and says, hey, you know, we have these boxes on the website. They need to be different colors. And so you write your CSS and your JavaScript and to do some fancy things like dynamically setting their colors and doing weird things like that. And so you build up your code and you're like, oh, great, I got this for each. I'm going to loop over. I'm going to randomly generate a color, set it the background using some really crazy looking JavaScript code. And you feel pretty good about yourself. But then your boss comes and says, well, we want to add circles too. They also need to be random colors. And you're like, well, the code, I already kind of did that for the squares, so let's just copy that and change a couple things, like the circle and things like that. This is obvious. This is pretty trite and trivial, but if you think of yourself on your project, you might have done this. You're like, I know someone did this somewhere, and you like find it, and you're like, oh, I'm just copying 5 or 6 lines, and you put it over here and change it enough where you feel kind of good about yourself. But if that happens over and over again, and it's not just you, but it's all your coworkers that are doing that, it gets a little gnarly, and it gets really hard to go back and figure out, well, what can we refactor? Has anyone done this? Is it just me? Okay, thank you. So it obviously smells because you're copying and pasting. Okay, that's not good. Typically, and I've done it, so I know it's not good. So wouldn't it be nicer with some tooling? Well, there's actually 2 tools. One's called JSInspect. It will detect copy-paste errors in your code. So you You install it. It's not npm. You do npm install JSInspect. You can run against your code, and so actually I took these algorithms and I put them in 2 different JavaScript files. So I'm not cheating by putting everything in one big file. And I ran this particular tool, and I made sure the lines were different. It wasn't just 0 through 5 and 0 through 5. It didn't exactly match up. I put code before and after and tried to make it sort of legit, even though it's a trivial, made-up example. But they went ahead and found the problems. It says these lines of code and these lines of code look very similar. You should probably think about refactoring it. So this is a good opportunity to pinpoint parts of your code that might need a little attention. The other one is JSCPD. So I try to remember that one. Anyway, but this one's cooler because it works for multiple languages. It's not just JavaScript. This can work for TypeScript, C#, Ruby. It actually also works for CSS, SCSS, HTML, and lots of other languages. So this one, you have to tell it what language you want to support. So, and this one has tons of thresholds, like how specific you want to be, how generic you want to be. Because some code is very similar, but it's enough different that you think it's okay. But this tool will let you tweak how fine-grained you want to do your comparison. And obviously, those tools you can hook up into your Gulp system or your Grunt or whatever, if you use Broccoli or whatever tools you use to automate your system. So obviously, you need a refactor. So this is really just an exercise of finding common bits of code, pulling them out into functions. I'm not going to bore you with that. You can make a double $sign because it's twice as better as jQuery. And then here's my random color. If you're like, oh, I still have a little bit of code that looks very similar, so you pull that out. And again, it's just thinking like a programmer, like what looks similar, let's pull it out. So whatever. So the resources, the code pen with those examples you can look at, and here's the 2 tools, JSInspect and JSCPD. I ran our code base. When I found out about these, and I know I'm going to talk about it, I ran it against our code base. I was a little scared because it's a pretty big code base. But I was pleasantly surprised that the main area that it pinpointed was a bunch of transforms that we have when like data comes from the server and we like massage it to look like what our app expects. There was some duplication there, but it kind of made sense, and so I felt good that it didn't blow up more than it did. So, so that might be something interesting to put into your code system. All right, the next point is incessant interaction smell. I was having a little crazy with alliteration. Sorry about that. So here, let's imagine you have an autocomplete system or something. We're going to pull it out, add an event listener, which does an AJAX call because you're typing in autocomplete. It goes up the server, pulls back some options. You've all used autocomplete, right? Now, I'm not going to show you the code because the actual code for the autocomplete is not all that interesting. But can anyone spot a potential issue that might, even in these few lines of code, that might be an issue? Well, minus console log. That was but yeah, you shouldn't have those in production either. So, anybody? It is a real event. You could change it to key down or key press, but input works as well. So the issue here is, why does it smell? It's way too chatty. If I'm actually making an AJAX call for every input, it's really doing a lot of talking to your server. Your backend friends probably won't like that too much if you're peddling the servers. So every input change I make is making a call, a potential call to AJAX. So that's not probably what you want to do. Imagine this is on the scroll event, or really anything that happens a lot. Now, scroll event happens a lot. I don't know if you've ever looked to see how many times it's called. You probably don't want to respond to every single scroll event. It's ridiculous. So what do you do? What do you do when things get crazy? Well, one thing, you can throttle it. So how do I throttle it? Well, unfortunately, there's a underscore or load dash has some nice helper methods. One is throttle. So what you do is you just wrap the function that you were going to call and put throttle around it. So underscore is the name of the library, or load dash. Say throttle, and then give it a parameter of like how often do you want this thing to occur. So what happens, I'm going to type a whole bunch of things, but it's only going to trigger that function at most once every 500 milliseconds. So that's much better. You notice it only potentially called my AJAX call like 5 times, even though I typed a bunch of letters. Now that's still not very good because what if I really don't know what I want yet when I'm typing. I'm just kind of like, whoa, whoa, whoa. It really doesn't make sense to make the calls every time because I haven't even told you what I wanted yet. So that seems a little aggressive. Anyone say a better way to do this? Yes. So what? There you go. Good job. So there's another one called debounce, and really there are good use cases for either of them. But what the gentleman back there mentioned is debounce. It's different. So instead of saying at most do once every 500 milliseconds, what we're saying is wait until you're done triggering that event for at least 500 milliseconds. So what that looks like is I can type, wait 500 milliseconds, and then it makes it one call to the back end, which is probably what you want. The user, hasn't really told you yet what he really wanted, but once he's done, he really wants the answer. So it's kind of a trick. So debounce is usually what you want in that case. With scroll events, debounce might not be what you want. You might want to throttle a scroll because you want things to happen as you're scrolling. You don't want them to scroll, wait, and then do whatever you want to do. So depending on your situation, you would swap between the two. Here's the resources. I prefer Lodash. I mentioned underscore, but Lodash, we use it some on our system. It's actually modular, so especially if you use CommonJS or browse-verify or something like that, if you just want to use the debounce method, you could just pull that one method in and not the whole library, which is kind of cool. Whereas underscore, you have to pull the whole thing in. So Lodash is a lot faster than underscore too. And the guy who wrote it, John David Dalton, really bright guy, and yeah, he changes it very frequently. All right, so the next point is the anonymous algorithm smell. So I mentioned, the exact code that I said was good on the previous slide, I'm now saying is smelly. And we've kind of done this a couple times because we can always make things better. In this case, it smells because we're using an anonymous function. Now, that's not bad per se. I use them. But it gets into a situation where it can actually be problematic. So let's talk about this for a second. So there are some reasons why you might want to name your functions. I'm not being dogmatic about it. I just want to let you know that there are some good reasons. One is for stack traces. If you've ever gotten into a situation where you're having performance problems with your website, it's being sluggish, you're trying to do some profiling and figure out what's wrong. If you don't name your functions, it gets really gnarly to try to figure that out, like what's the source of the issue. The other reason you might want to name it is for dereferencing. I'll explain that when I show you the code. And code reuse. Like if you want to use the same function again, you probably have to name it so you can reference it. So the first one, for example, so here we have our autocomplete writing the input event, and here's our function. Let's say we want to profile this. We want to figure out how long our input function is taking. So I open up Chrome DevTools or Firefox or whatever. I start a profile, a memory profile. I stop it. Can anyone tell me where in here is this anonymous function? Is it that one, or is it that one, or is it that one? We don't. It's not really obvious to look at here. Where's the code of this console log? So that's where it becomes kind of a problem. Now, it was the second one. If I open that up, the anonymous function, you'll see inside there's a log, which is the console log that's here. But I would have to go through and open each anonymous function to figure out which one it really is. And that's kind of cumbersome because this is like 4 lines of code. It's not a complex system. Imagine your code base trying to figure this out. So one thing we could do is we can actually name our functions right here, where normally you would have an anonymous function. It looks a little strange at first because a lot of people have never done that, but it's perfectly legit. You're giving it a name so that when you run your profile, it actually shows up on the top level with the name that you gave it. Now, I wouldn't do this probably for all things, but if there's a piece of code that maybe you think is having issues, this might be handy. Here it shows a couple. I could open it up and sure enough, logs there. However, we have a problem. When we use our handy-dandy debounce or throttle, what it really does under the covers is creates a new function, wraps your function, and it has all the logic, you know, should I call it or not? So we run into the same problem we had before, where our bounce gives us a U, which is not really handy. That's what underscore named our function, U. And if you do this a lot, if you bounce lots of different things and throw all different things, then U would show up a lot here. So that's not very helpful either. So what can you do in that situation? Well, there's this handy-dandy drop-down where before it was tree top-down, and that's the default. If you switch it to heavy bottom-up, and you name your anonymous function, well, it's not anonymous anymore, you name it. But if you name it and say bottom-up, then it'll bubble up the matches that I gave it to the top. So I kind of reversed the call stack. So now you can easily find your stuff, even if you have some wrapper function that is doing something intelligent. So the next thing you might want to do is you might want to have an anonymous function, but immediately inside you want to remove it. Have you ever had an event listener that you wanted to happen one time and not do again ever? There are ways to do that. It can be tricky or a little gnarly. Or maybe you want to listen to some event that's being dispersed, and immediately when you receive it, you want to unsubscribe from that event. Same idea. So here we have an advent listener. We say click. We name our anonymous function. We do our thing, and then since we have the name, we could remove the event listener from the button and hand it the handler that we're currently in. So we don't want to remove all handlers. We just want to remove the one that we're in. So that works. So when I click the first time, it says kaboom. When I close that, it removes the click handler. So if I click it again, it actually doesn't say kaboom anymore. So that could be a handy way to use naming your functions. And the third one, I don't even probably have to say this, if you want to reuse the same function over and over again, you kind of need to name it. So I can have a kaboom function, and if I click or mouse enter on things, I can reuse it. So no rocket science there. The main resource is learning how to use your dev tools and the profiling if you haven't done that before. All right, the next point is the switch statement smell. So here I'm calling this smelly code. I use switch statements. Everyone uses switch statement before. Okay. It's basically a glorified if then else statement, many of them. So you pass in some shape. So we want to get the areas of various different shapes. So I want to get the area of a triangle. Pass in some options, get the area of a square, rectangle, etc. It comes in, figures out the type, and then there's different algorithms to figure that out. And but can you tell me why that might be smelly? Yeah, so it's somewhat brittle. That's good. Unfortunately, the code I show you will not fix that problem, but it'll fix another one. That would be another sample. That's good. That's another smell. Actually, that's a good one. It violates the open close principles, and that might be a new term to you. But so what that kind of states is that we, in software, in order to make something not brittle, like we don't want to make brittle code that breaks. And so the open close principle basically says, if you make some code, don't make it so you have to go back in and change it. Make it extendable, like you could add functionality to it, but don't actually change what's there. Because if you change what's already there, the chances of you breaking something that's in that function is much higher than if you augmented and added new functionality to the system. That might sound like magic or words, but we'll show you an example of how we can do that. It's part of the solid principles. I don't know if you've ever looked in the Uncle Bob's solid principles, but a lot of good stuff there. If you want some outside learning, it's generic to any language. Just some real good design principles. So if we add a new shape, let's say we want to add a circle. So what we'd have to do to add a circle is add another case statement. So we'd have to add this. It wasn't there before, but now I'm changing this code. What if I had accidentally wrote a piece of code in here that had a bug, like it threw an exception, well, we would essentially broken all the other shapes as well. If there was a bug on this line, then I could no longer possibly look at other things, and it just becomes problematic. So what we do? Well, we could implement the strategy design pattern. So if you've ever looked at design patterns, strategy is a good one. Anytime you see a switch statement, you could usually rewrite it with a strategy pattern. That sounds a little ambiguous, so let's talk about it. And this code might look a little foreign to you, and that's okay. I mainly want, you could get the slides afterwards, I mainly want you to think about possibly solving problems differently. So now is everyone familiar with the IFI? I don't want to go too deep, or a self-executing anonymous function. There's different names for them. Okay, immediately invoke function expression. It's all the same thing. It's this crazy syntax where I have a function, and I'm calling itself, and I'm passing weird things into it. So if that doesn't make sense to you, just ignore that for now. But essentially, we have multiple files, and each file describes a shape. And so this particular file, we're describing a triangle. So we're going to have a function, a constructor function called triangle, and we're going to pass in our options to the constructor function, and then we'll add some methods to the prototype, so get area, and we'll repeat this over and over again. We'll have another file, maybe for circles and squares and things like that. And then we have this generic piece of code down here, and it looks a little funky. It's called the area. Our API will be the exact same as it was before. We pass a string triangle, we pass it options. But what happens now is we pass in the shape. We now have a shapes object with all of our various different shapes. We pass in a string, which maps to like the triangle constructor function. And then as long as it is a shape, as long as it's a function, we new it up, we pass the options, and we get area. It looks a little funky. It might take a while if it's new to you. But the functionality is the same, the API is the same, but what does that give us? If we add a new shape, then we just write new code. We don't modify existing code. So we have a different file that's separated. All the code in here is isolated. It's not touching any of the code that we wrote before. So we're extending our shape system. We're not modifying it. And then it just works just fine. Again, there's a code pin with the various different examples. Somewhat trivial example is just showing shapes. But there's a free ebook that Adi Osmani, he works at Google, that wrote, which talks about tons of other design patterns. I'd recommend looking at that. All right, the next point is the temperamental timer. Does anyone use set interval here ever? Okay. So it could be a problem, so we're going to talk about it. So this particular piece of code, and this is, again, highly trivialized, we have a set interval. We want to do something every 3 seconds. So that, for set interval, you pass it a function and a time. Within our interval, the thing that's going to call every 3 seconds, we possibly might do a process that takes a while. Maybe an AJAX call, maybe some intense whatever you're doing. Can anyone tell me why that might be an issue? Yeah, exactly. So, and you can kind of see it here. I have this long process. I'm generating a random integer from 2 to 4 seconds, but I want my intervals every 3 seconds. So I could get in this case, and I'll show you what. It might be easier to see what it's actually doing. I'm going to start it, if this works. So I'm going to start my set interval. It's going to, you notice it started it twice because my process actually took 3.5 seconds, and I'm looping over every 3 seconds. So I'm potentially kicking off something a whole bunch of times, and you notice they're kind of building up, and it could get really awful. And imagine if it's an AJAX call, you probably have some issues there. So I typically try to never use set interval if I'm doing things like this, where the thing that it actually does might be time intensive. So what do you do instead? So you set timeout, but set timeout, it only happens one time, right? How does that solve anything? Well, let's look at an example. So here I'm going to say set timeout. I'm going to get a function, but I'm also going to give it a name. So this kind of goes back to what we talked about before. You could actually name your functions. Even if I don't want to reuse this again, it's helpful to actually name it. So I'll actually start the timer, I'll do some long process, but my long process I'll make smart enough to have a callback. So it'll tell me when it's actually done. So I tell it how long. When it's actually done, it calls my callback, and then I say do another set timeout using the same function that you used before and use the same time. Now it's a little redundant because I have to tell it the interval twice, but I don't have to repeat the function that actually happens because I gave it a name here and here. And so that will clear up this particular problem. So they'll always be in sync. We'll start it. We'll wait till it finishes. We'll start the next one. Wait till it finishes. And at this point, they've all been short, but hopefully we'll see one that's over 3 seconds. Yeah, so that one took over our normal set interval that we did in the previous slide, but now they're still in sync. So anyway, something to think about. If you have a set interval and it's not doing really intense stuff, then it's probably fine. But definitely think about that. You can get some race conditions. All right, this one's a little bit harder to spot. This is called the unconfirmed code smell. Has anyone ever written code like this, where you have a document ready and then there's just a bunch of code inside of it? Probably much everyone has done that. Now, this could be a problem, and primarily it doesn't show up at first because you're like, oh, everything works just fine. But what happens when someone says, hey, do you have unit tests around that? And you're like, ooh, that's a good idea. And so you sit down. So I'm describing myself here. So you sit down and you're like, I'll make some unit tests. And then you're like, oh, my goodness, there's no entry point. Like, everything starts in document ready. So if you write up your unit tests like with Jasmine or Mocha or whatever you do, usually you want to be able to recreate things when you want them to. And if all your code just immediately fires, there's no way to replay that. It's just really hard to actually do unit testing, which is one good reason to kind of do it up front instead of later. Even if you don't write tests before you write your code, if you write it shortly after you write your code, then you're going to be in a much better place. So what you could do instead is actually have an init method or initialize or something, and then put kind of your code in there. Now what that gets you is, and so this is what I'd more rather see in someone's code. You have a document ready, which is just kicks off some other piece of code. That way in your unit tests, you're not depending on document ready because that's only happens once, right? And this way you could actually have some cleanup code, and then manually init when you want to, or not init it and actually call the other methods, things like that. So this is more the singleton model. You could go a different model and use the constructor function model, where you have something that you want to new up, which kicks off everything. So possibly your constructor would do some of the init stuff. There's lots of different ways to solve this problem, but the problem is that your code should be testable. This one's called the inappropriate intimacy smell. I had fun with names, sorry about that. All right, so this is a problem where you think you're writing code modularly. Oh, I got a shopping cart, yay for me. I got a product, good on me. And then you're using it, and then this new app comes out, and you're like, well, we need to reuse a product. So you wrote one before, so let's reuse it. You're like, great, I want to use my product. But we don't have a shopping cart. Like, that's fine, I wrote modular code. Well, if we look closely, the product actually has a reference to the shopping cart. So they're tightly coupled. We thought we were writing loosely coupled code, but they're not. This is actually a hard thing to detect with tooling, that this is a problem. It's more like conceptual, like, oh, I shouldn't have done that. So there are several ways to solve this. It smells because it's tightly coupled. So dependency injection is one way to solve it. Some libraries kind of do this out of the box, like Angular is really good at this. But you could do it manually, and we're going to show the manual way. Or you can use a message broker or event bus or something like that, and we'll show what that looks like too. So here's not much different, but what we're doing down here, and I'll show you the code up here in a second, but we're going to new up our shopping cart, but when we new up our product, we're actually going to, in the constructor, we're going to pass anything that we depend on inside of it. So the product depends on a shopping cart. So we'll pass that in. And then inside of our constructor, we'll actually save off the shopping cart into an instance variable. So that way when we use it later, we're referencing the instance variable and not something that's global. It seems like a little thing that's changed, but it actually frees you up to pass in a mocked shopping cart. So if you're doing unit testing, you can pass in a fake version of the shopping cart. Because you don't really want to test the shopping cart so much, you just want to see if it's being called the right methods and things like that. Or if you have a super awesome version of the shopping cart, you can pass that in instead. So it's much nicer. The other one is a message broker. So you have like a common object that handles triggering messages and listening messages. I'm using Postal. A good friend of mine, Jim Cowart, wrote it, but you could use lots of other things. So in this case, the common dependency for both of them is Postal. So they both know about this Postal. The product, when it goes to add to cart, it just says channel. I'm going to publish the fact that I'm adding to the shopping cart. And then the shopping cart listens, hey, is anyone adding something to the shopping cart? Let me know. And so it's subscribing to that. And when that happens, it'll add stuff to itself. So they're sharing the kind of the message bus, but they don't know anything about each other other than that. Well, they do know the string that they're publishing and listening to, but they're much more decoupled than before. And again, resources, the library that I use to do that is Postal. It's really nice. All right, I'm sure everyone has done this code because I have done it. It's the this abyss smell. I could talk a lot about this, but I'm not going to go too much. But has anyone ever written this code right here? Yeah. Some people call it bad or self, or you can maybe call it selfie. It makes more sense. But lots of different names. But usually they're saving off the this variable because what they want to do is inside this scope, they want to somehow call something that was in the scope outside of it. So they save it off so that they could call clean. Because if they didn't do that, if they say this.clean, it would actually not reference the person object at all, and it would just blow up. So a common way to do that for many years was to save it off as another variable and reuse it. But we don't have to do that anymore. There's lots of alternatives. One is bind. So does anyone have to support IE8? Okay. Not many people, but even if you do, there's the ES5 shim will actually give you this functionality. So, and shimming is technically a polyfill, but it will provide these methods in IE8 and just won't mess up all the new browsers will use their default stuff and just ignore the shim. But you could do this in IE8 if you have that. So anyway, so what we could do inside our function, I could say I want to bind the function. When you call yourself, I want to bind the this that you're going to have inside of you to the this that's outside of you. It looks kind of funky the first time you see it because I have this 3 times and it's kind of cascaded like a little slide or something like that. But so it works. It passes the this through the this context. So that's one way to solve it. But hey, why even do that? Did you know that the for each method has a second parameter where you tell it what you want this to be? So I could do that. I don't even have to use bind. Of course, for each is only 9.9, so still have problems. But the ES5 shim will give you for each, so you're safe there. If you're using ES6 with Babel.js or Traceur or one of those other things, if you use the fat arrow, which is this syntax, if you don't know what that means, it automatically passes the this context from the outer scope into the inner scope. So I could safely use this inside my scope, and really it's referencing the this from the outside. So I could do this. But why even do that? I'm just cleaning my teeth. Why just not use functional programming and say my for each, I want to call this.clean, and it will just do it for the whole thing. Anyway, now obviously if you're doing more than cleaning your teeth, then this won't work. But you could do other fancy functional techniques. So all these examples are on the code bin if you want to look at it. But basically, if you find yourself saving off this to that or self, there's a much better way usually. Even jQuery and jQuery 1.4, which was quite a while ago, they introduced the $.proxy method. I don't know if you've seen that, but it's doing essentially all these things because developers didn't know these techniques existed. So jQuery was like, well, we'll give them the proxy method, so it's a little bit easier. All right, we're close to done, so don't worry about it. Crisp concatenation smell. Have you ever written this before? I have. Okay. Do you like it? I don't. You might love it. I don't like it. I think it smells. So it smells because concat as a cat that's con. So anyway, it's bad because it's string concatenation. So the main reason to get around this is like templating engines, but those are so big. Thomas Fuchs wrote this tweet-sized JavaScript templating engine. So this actually fits in a tweet, which is really kind of cool. But the way you use it, and I've used this on really small projects where I didn't want to have something huge. So you call it T, which you can call it whatever you want. You pass in a string which looks almost handlebars-ish, if you've ever seen that. But you pass in your options, and the keys of your object match up to these curly braces, and it just swaps them out, which is really kind of cool. That's pretty much all you get, but that's pretty nice. It cleans up the code quite a bit. You don't have all those pluses. Now, obviously, behind the scenes, it's kind of doing that crazy stuff, but and just ignore all this regular expression business. Yeah. So another way you could solve it is ES6 template strings. Now, again, you might not be using ES6, but you could use the backtick. So it's not actually a quote, it's a backtick. And if you use the backticks, then you could use $, curly brace, and reference parameters that are in scope. And it just replaces them, which is really kind of cool. You go one step further, and ES6 supports multi-line template strings. Yay! Clapping. So you could actually have ticks, put things on different lines, and end with a backtick. And that works just as fine, too, so it looks a little bit nicer. Now, obviously, if you have a much more complicated system, you might use the Lodash or underscore template engine, which is based off the micro templating engine John Reddit wrote many years ago, or use Angular or React or Ember or handlebars, or there's tons of options, but just don't use tons of plus signs. So here's some links for some handy dandy tools. jQuery inquiry. Has anyone written this before? It's awful. It's great that you could have a Fluent API that's chained. Has anyone ever tried to debug that when it goes wrong? That's where it becomes hard to do. It's great that you can chain, but you have these weird things where when you do find, you have to say end to get back to the scope that you were before, because every time you call find or filter, jQuery actually creates a new internal object that looks different, pushes that on the stack, and you can actually push tons of these on the stack. If you want to get back to the previous selection, you have to say end to pop them off. It's really complicated, really quickly. And jQuery fails silently, so if you wrote something that doesn't make sense, it will pretend that it worked, and you can keep doing things again and again off of it. So debugging it gets really gnarly. But it smells because there was an extreme chaining, in my opinion. So you could refactor it. This looks completely different from what I just wrote. I kind of did that on purpose just to show you that, hey, you could think differently about your problem. This does the exact same thing as the previous one, but better. So has anyone used on before in jQuery? Or has anyone even used jQuery? Okay, some people. Okay. Sorry, I probably shouldn't have said that last statement. So the on method, there's two versions of it. There's the version that you pass 2 parameters, and there's the version you pass, I don't have a third hand, but 3 parameters. The 3-parameter version is much smarter than the 2. It does event delegation. So what we could do is we could grab the document, tell it to listen to mouse enter and mouse leave events, tell it to only listen for those events on this particular component, and then trigger some function when it happens. I'm actually listening to 2 different events, so when I get inside my event listener, I could grab the E, tell it what type I was actually doing, and I could toggle a class on or off based on the type. It's a little strange if you've never seen it before, but what we're actually doing here, you notice what we're not doing? We're not waiting for document ready to write any of our code. We're actually running code before document ready. Amazing. Because most people don't know you can even do that. Here again, I'm doing that. Why can I do that? Because I'm delegating to the document. I'm not relying on any DOM to be present, actually a DOM element. In this case, I'm listening for clicks, listening for the component. So, and this is also, does anyone remember how live used to work? I'm dating myself. But using the 3-parameter version of on is like what the live method used to do, where it delays execution until you actually do something. So when stuff comes in with Ajax and you add stuff to the DOM, you don't have to rebind everything. It just magically works. So I'm kind of leveraging that idea of delegating. So the only thing that I really have to wait for document ready is for these buttons to exist so I can add a class. So the code looks an awful lot different, but I can debug this a lot easier when things go wrong. Just to show that they work just fine, both of these, this is the old way, this is the new way. I'm clicking things, it works. I'm clicking this one, it works just the same. But they work very differently. The original code is binding directly to the elements, and the other one is delegated. And my code's there if you want to see it. This is highly debated. I'm calling two-way data binding a smell. It seemed great when Knockout.js came out and Angular came out, and people raved just this two-way binding. You change one thing, it automatically changes another. You change this, and then it changes that. And it's really great for demo apps. So when you're even the inventors of Angular have said this, and this is the YouTube link to the exact moment when they say it. For large applications, two-way binding becomes a code smell. Because what happens when you encounter a bug in your system, you might have no way to recreate that. Like, how did this happen? Because so much magic is happening of data flowing around that it can really be very difficult to figure out how to fix something. So it smells because it's hard to track the flow of execution of data. And so I'm not saying you have to use React, Facebook's React, but they have this Flux architecture, which describes how an application could work maybe in a more sane approach. Like data just flows around in a circle. And it sounds somewhat inefficient, but it's a lot easier to get a developer's head around a problem if you could actually recreate it consistently every time. So there's some resources if you want to look into that. The future version of Angular, they want to actually have a way to do one data flow instead of two, because they realize this is an issue. And again, this is the link to the exact moment where he says it. So the last time I gave this talk, I had a great question in the audience. Well, it was online, so it was different. But someone was like, hey, for the first 3 points, you had some really cool tools to tell me that I'm doing something that might be a smell. Are there tools for the other ones? I was like, oh, no. But that would be really cool. So what I did is I made tooling to detect these things. So ESLint, which is the thing I asked if anyone knew about, and very few hands came up, it supports custom rules. You can make your own rules. So I was like, well, let's make some rules for the things that I said were smelly. Some of them were highly subjective or very difficult to actually detect, so I didn't do all of them, but I said there's a rule to say, yeah, don't use a switch. Now, again, if you don't like that, don't use the rule. I said no complex switch case. So I'm almost okay with a switch as long as each case doesn't do a lot of things, like it's a call to another function or just a one-liner. But a danger you get with switch statements is you want to, oh, I need to do one more thing, and you start adding code in each case, and it gets out of hand. So the no complex switch case allows simple ones, but not complex ones. Right now, it only lets you have one statement. I want it to make it better so you can actually pass in a number to tell it a threshold. Let's not do that yet. No set interval, and that's pretty much it's there or not. So, but the cool thing about ESLint, it's not just it fails or not fails. You could tell it to ignore it with a 0, warn about it with a 1, or give an error with a 2. So a lot of the linters, it blows up in your face or not. ESLint's a lot cooler because you can kind of give it an error threshold. So I supported not assigning this to another variable, which helps enforce you to not do the that equals this thing or self equals this. And I wrote a rule for no complex string concatenation. Again, I need to pass in a number for this one. Right now it's extremely aggressive. I only let you do one string concat, which is kind of insane. Like, don't use that. Just wait till I fix it. So you can actually pass in maybe a 3 or 4 as a threshold. Now I'm currently working on the chaining, complex chaining. But anyway, if you're interested in any of that, the tool is called ESLint plugin smells. So ESLint's really cool. It actually uses an AST parser, an abstract syntax tree. So it actually goes through your code, makes a tree, and it triggers all these. Like, hey, I just found an expression, or I found a switch statement, and it lets you plug in, listen to those, and react accordingly. So it's kind of fun to learn the last couple days as I was running these rules. And just to show you, it's out on in GitHub. Here's the rules, and has unit tests and all that Great stuff. So that's it. I hope you learned something. If you have any questions, we could field some. The link to the actual slides are bit.ly/smells. Anyways, anyone have any questions? If not, you feel free to come up after me or tweet me or email me. Yeah.
For the incessant interactions, though, do you have any other methods other than throttle and bounce?
I don't. I've used both of those to get around that problem. If you have a different scenario that you're having issues with, I'd love to talk about it, but for the most part, those two have solved all the problems that I've needed. I used to use an Allman, I don't know if you know him, he was big in the jQuery community, he wrote Grunt. He had his own versions of the bottle, sorry. He found some problem like the bottle. And that was pretty cool. I'd use that. But then I moved to low-dash _, because I don't want another dependency. But yeah, if you have a problem, just let me know. We can talk through maybe how you can solve. All right. Well, thanks for coming, and hopefully you learned something that's helpful.
All right, we're going to give it up for a line one more time. Last announcement. We're starting to commission some NashJS t-shirts. So if you or your company are interested in maybe sponsoring the t-shirts, get your logo on the back or something, I'm not sure how we're going to do it yet. Hit me up on Twitter, and we'll get the ball rolling on that. Anyways, thanks to everybody for coming out. We'll see you next month.